difference. W2A, W3A. That again tells us what? That 2 must come before
3.
2 must come before 3. So you keep on drawing these things, okay? Then keep on going. W2, and this is R2, same thing. This is W2, this is W2B, same thing. Let's go with R3. R3A. Go on. What is this here? R3A and W3A. That's the same thing. Same transaction. That's it. Nothing. Let's go with W1B. This is W1B. This is A. Nothing. This is B. This is B. 1 must come before
2.
2. Keep on going. 1 must come before 2 again. This is W1B, W2B. One more time. Okay, right?
Mm-hmm.
Let's now take this one. There's nothing here. Take this one. Well, this is 2, this is 2. Nothing. So what do we see here? 2 should come before 1. 1 should
3.
come before 2. 2 should come before 3.
3.
So this is a serial schedule. There is no cycle here. So the answer to this is T1, T2,
T3.
T3.
T3. That's it. So we got serial schedule only one. T1, T2. We can't make up any other serial schedule here because of the diagram. Diagram tells us start here, go through here. Okay, we got to move fast now. Let's look at this one. Okay, now start with R2A. What else is A? Oh, here.
W3.
Again, reading. No, it's a reading. But you go here. This is writing. So these two right here, they tell us that 2 should come before
3.
3. Then start with this one. Second one. This is B now. Well, this is B2, but that's the B same. This is R1. This is R2.
R2.
It's a reading. So nothing conflicting. Reading doesn't conflict.
Mm-hmm.
And this is 1 itself. You can't do anything.
Transaction.
Okay. So this is the second one here. So that will says 1 must come before
2.
2. So 1 should come before 2. Let's done with this. Let's look at this. W2A. W2A.
And R3.
And now we have to look at reading or writing. Okay. Hey, A. Oh, well, here. W.
R3A.
That means 2 must come before
3.
3.
3. So we got that here. 2 must come before 3. Okay. Where would it be? Here, right?
Mm-hmm.
Now there is another A. W2A
W3A.
and A. So that means 2 must come before
3.
3. Okay. Now go with R2 here. R2B. Well, what is happening here? Go down here.
W1B.
W1B. 2 must come before
1.
1. So we got here arrow going in the opposite direction. 2 must come before 1. Okay, we have to finish the diagram. Okay. 2 must come before. Okay. And what about this? Nothing. What about the last one? Nothing. So R3A and W3A, no problem. Nothing. And W1B with this, nothing. W1B with W2B tells us 1 must come before
2.
2. Well, here is a problem. 1 must come before 2 and 2 must come before 3, and then it says 2 must come before 1.
1.
So you cycle here. Cycle here.
Mhm.
And this is not conflict serializable. Okay? So not conflict serializable. Okay? No good. Nothing here. This is okay. And this is the schedule. All right. Now let's come here. Over here, I wanted to give you some more examples on group by and the having clause. So I'm going to treat these clauses first separately. Group by. Okay. So what happens is, if you are interested in getting some stats or some information of each group, okay, of certain groups, then what you do is you group them. So if you have the whole data, you group them into groups, whatever kind of groups you want. And then, of course, after you group them, you can do anything you want. So let's say here, first question is colleges. Give us the colleges by their college enrollment by state. So that means for each state, we want to find out the total enrollment of all the colleges. If it's New York State, doesn't matter how many colleges are there, we want to sum up all the enrollment. New Jersey, all their enrollment. Connecticut, all their enrollment. Ohio, all their enrollment. Okay? So that means we want to group the data by state. Group by state. Okay? Where the data is coming from? Well, college has in it what? College name, enrollment, and state. So all the information we need is right here. Okay, so what do we want in the answer? We want the name of the state. So what should we write down here? It just said state, right? Name of the state was written by state. Okay, state, comma, we want sum of the enrollment. Okay, so what we did was we divided this information of the colleges. Okay, let's say we did this, and all this data here is for New York. You can look at the data, but we have very little data. So let's say all this data is for New Jersey. Okay, and all this data over here is, let's say, Ohio. Okay, now what is in this data? Can anybody tell me? When you divide up this data, what is in this data? Well, you have to look at the tuples in this. In here, all the tuples still have what? What do they have? College name, state the name is only New York, and they have enrollment. In here, all the colleges, different names, but the state name is always going to be Jersey and their enrollment. Here, all colleges names, different names in the state of Ohio, state name is only going to be Ohio. Okay? So what do? We take here all the enrollment and sum it. And then we sum it here, state by state. Okay? So it's very easy. State, sum the enrollment by state. Okay? Name of the state and the enrollment from colleges. Okay, here's another question. For each college major, okay, here we are talking about a major. Okay, for each college major, compute the minimum and maximum GPA. Okay, something is wrong here. I got to correct it. Okay, oh, maybe I write it up here. It is SID here. Okay. All right. So what do we say? Okay. So what we are doing is, for each college and major, we want to compute the minimum and maximum. Okay. All right. So students who apply to these colleges, we want to find out what is the minimum and maximum GPA they had. Okay. So what are we looking for in the answer? You should always first understand the answer. We're looking for the name of the college, what is the major, and what is the maximum and minimum GPA for that given major. So what do we need? We need student, that's where we're going to get the GPA, and we need apply, that's where we're going to find out that they applied to some college. Okay, so we want to make sure that these students apply to the, we are talking the same student, therefore we say S.SID is equal to A.SID. Or we could have simply done natural join and it will still work. Okay, or we could have done using. Okay, now we want to group by college name and major. Two things. Okay, college name, comma, major, and the end of the statement. Any question here? So for each college name and major, we can calculate the maximum and minimum GPA. One thing I have to tell you, if something doesn't appear here in group by, it cannot appear here. And I'll show you why, okay? If it doesn't appear here, it cannot appear here. The only extra things which can appear here are which are computed. Right here, enrollment is computed. Major, maximum, and minimum GPA is computed. Okay, this example will show you why we cannot do what I said. Okay, here, number of colleges applied to by each student. Number of college applied by each student. You know, how many colleges each student applied to. Okay, so let's see. So what we're really talking about is, look at each student, separate the data. We look at the apply, we look at the applied relation, right? And see, separate that data by SID, because it has SID and college name, and it has major and it has a decision. So we separate them by each student's SID, and we just count them, how many tuples are there. That's it. Okay, here. Select student SID because we want to find out from the student. So SID here appears two places. It appears in the student and it appears in the apply. You must say student.SID or apply.SID. Where are you getting SID? If you don't do that, it's an ambiguity and this will not run. Okay? And then here student as apply as group by SID. Why not just say SID? We can't say SID because, as I told you before, it's ambiguous. And we are talking about students who applied. Okay? Something is missing here. What is missing? I purposely missed something. Okay? What is missing here? What is missing in this case? In this statement? Come on, guys.
The college name?
No, not college name. When you say from student and apply, what else you have to say? They are being joined. This statement has to be here, this one, where S.SID is equal to A.SID. This one, this right here. Okay, that joint statement has to be here. So group by SID. Okay, so as I told you why we need to say SID, why not just SID alone? We had to say S.SID. There's something else wrong here. We put here dot saying that all the column or whatever you will have, you divide them into SIDs. So let's say what's her name, Amy in the top has 4 lines. Okay, 4 lines Amy has. If you look at the data, let me see, Amy has how many lines? 1 2 3 1 2 3. Amy has 4 lines. Now what happens, Amy is applying to NJIT twice. So this won't work. We want to find out number of colleges applied by each student. So we are counting the duplicates. So how do we take care of this? What do we say here instead of saying star? Star will count all the lines.
Do we do distinct?
Yes, you have to put here distinct what?
College name, like C name.
How could we distinct the college name?
Hold on.
Distinct SID here. What are you counting? Okay. We are counting the colleges, right? So we can say distinct college name. You are right. Okay. Because, okay, if you say distinct SID, it will also work, right? If you say distinct SID, will it work? No. Will it work? If you look at Amy, 1 2 3 NJIT, 1 2 3 NJIT, then 1 2 3 Stony Brook and 1 2 3 Cornell. Will that work? No.
No, because it's gonna show.
You will get 1 2 3. So we have to say distinct college
name.
Thank you. Let me write it down so that you can see it here. I will put it, where should I write it? Right here, right? Because I said here, what's wrong with it? So I say distinct C name. Okay? So this thing should go in there. Right in here. Okay? If you are just counting all the things, then you say star. But if you don't want to count all of it, then you say distinct. Okay? And you have to look at the attribute which you want distinct. Okay? All right, let's look at here. Now, here it was students who were applying to colleges. We want to find out how many colleges they applied to. Here, we want to find out colleges fewer than 1,500 applicants. Okay, now where do we get the number of applicants from? Well, if you look at the apply, it has SID, it has C name, it has major, and it has decision. So we don't need anything else. Okay, so we want the names of the colleges which has less than 1,500 applicants. Okay, so we get from apply group by what? College name, because we want college names. Now, once we split them by colleges, we want to put a constraint on it. I want to find out only those colleges which have less than 1,500 applicants. Okay, so I have count the number of the applicants. So I said count star. Okay, so if for each college there's a line, how many people have applied? Okay, let's say this is a NJIT. So it's 1 2 3 NJIT, 1 2 3 NJIT, Then there is somebody else apply to NJIT? Oh, that's it. Oh, wait a minute. 876 NJIT, 765 NJIT. Okay? So, do you want me to write down? 1, 2, 3, NJIT. Come on. 1, 2, 3, NJIT. And I have, come on, where is it? 678 NJIT. And I have one more. I'm looking at our data, okay? And 765. Okay. All right. So what we did is we have split this data group into colleges. Okay. That's what we did. Group by colleges. I'm just showing you for one college. So NJIT has these entries 1, 2, 3, 1, 2, 3, 6, 7, 8, 7. So we want to find out the applicants. How many applicants each college had? Okay. So we group by college name. We group by college name. Then we simply count. We'll count all these. 1, 2, 3, 4. Well, actually, that's wrong. Right? These two are the same. So what we want to say here? We don't want to say count start. We want to say count what? In parentheses here, what do you want to say? What do you want to say in parentheses here, guys? We want to say what? Just look at this data. Just look at this data. Please look at the data and tell me what we should be saying. Just look at this data.
Distinct.
What does
SID?
it will be distinct SIT. So you will have to say count in parentheses distinct SIT less than, where is it? What happened? I went outside. Oh, okay. I better forget that here. I go to the next line. No, it's not going to work here. Okay, so I have to say here, count distinct parentheses SID. That's it. Just leave that. Okay, so in here, I have to say count in parentheses distinct SID, parentheses close, less than 1500, semicolon. Any question? One more here. Major whose applicants maximum GPA is less than the average GPA. So we need to find out what's the average GPA of the students. Just look over here. The average GPA is select average GPA from student. That's it. Calculate the average GPA. And then we want the maximum GPA is less than average GPA. What is those measures? Okay. So select the measure from student and apply where S.SID is going to and group by major. Okay? All right. Of course, major comes from apply, and of course, students who are applying, it comes from student. So we're going to find all those measures. We just want those from student and apply. And we always have to have this condition which says we could have simply said here join them, okay, student and apply, okay, and group by major, and we are saying the maximum GPA of the student, okay, is less than the average GPA. So this is the maximum GPA by major. Okay, So we divided up the data by major and then looked at the maximum GPA of that major. And then we found out that is it less than the average GPA of the whole student body. So, okay, so take a copy of this, and this is it. Okay, make a copy of this. Now, make sure you understand how to use group by. That's why I gave you all these examples, because it was the same question I gave you in a thing where I said, what was that? Find the names. No, find total number of boards of each color. Okay. Each color. So you take the number, all the boards, and divide it up into different. Oh, wait a minute, I need a different color here. So you take all your boards and divide it up into colors, and then what? And just count the whole thing. Just count all the tuples. That's all you're going to do. And where does it come from? Let's look at it. Board has board ID, board name, and color. Okay? That's all you need. You don't have to go anywhere. So you have from board and group by color. Okay, so what happens is we have a bunch of these boards, and let's say here, and this is all boards by blue color. These are all by red color. These are all by green color. So let's say this is red, white, blue. Red color. This is blue color. These are all white color. These are all green color. Okay. So these are tuples in the board, right? We collected all green of them separate, red separate, blue separate, white separate. Okay. So now what do we do? We just look at how many tuples are here, over here. Oh, wait a minute. We need a different color now. So we look here, how many tuples are here? Just count them. How many tuples are here? Count them. How many tuples are here? Count them. And how many tuples are here? Just count them. We are not counting the boards. We are counting the number of tuples because these are correspond to the colors. So that is what it is. That's why you have here color count. Okay. Now the other part of the question people did wrong was putting and. Looking for a board which is white and blue. We don't have boards white and blue. Okay. We are looking for boards which are white or blue. So instead of and, it should be or. That's all. That was the only. Just like you are taking certain number of courses, you say I'm taking database, or I'm taking and I'm taking networking, and I'm taking something else. So you're not taking one course or something which has all these things in it. No, you're taking 3 different courses. So if you look at the tuple, either it will have white color or red color or blue color or the green color. So there's no board which is white and blue. So you have to say or. And it's very, very straightforward anyway, because we are asking for names of the sailors who reserved a white and a blue board. Okay? Just the names of the sailors. So you simply select, is this blue? No, here. Is this blue? Oh, it doesn't matter. So what do we see here? Select names of the seller. What are they? Last name. Last name appears only one place. Oh, it's all small letters. Last name. Just to be one of the names of the sellers. Okay. And we are going to have to use everything from boat. Let's also give it a name B, comma, seller. Let's call it S. And then we have reservation, reserves. Oh boy, it went out. Okay, wait a minute. Okay, let me just put it here. Here, reserves are okay. So we have to do that. Now what we have to say? Now we have to make the, if you want to say joins, you can use joins. But remember I told you, if you say two things joined, you can't say three things joined in one line. You have to put them in parentheses. Okay? So if you don't put in parentheses, then joins won't work. So you can say, instead of using this statement I wrote right here, you can say something like that. Let's see. Let's write it. Let's write it a different color. Okay. So let's say we wanted to use here join. So what do we say? We will put parentheses and we say both. Okay. Both natural join. Sorry. I use capital letters. Both a natural join seller. Don't even have a space there. So I have to go to the next line. Okay. Did I get it? Yeah. Parenthesis closed. Then I say natural join. Now I can say again natural join. And then I have to go down here. I have to say, oh, it won't work. I have to use more space. Reserves. I can do that. If I didn't do that, if I use this statement, then I have to say both b dot bid is equal to reserve dot bid. And then we have to say s dot sid is equal to reserve dot sid. You have to make sure that they have common attributes. So here I said both, wait a minute, guys. I think this may be wrong. Both natural join seller. Is that correct? Both natural join seller. That's wrong. This won't work. You see, both natural join seller is wrong. Both natural join is going to be reserves. That's what is going to be first. This is wrong. Both natural join reserve, and then we can say natural join then we can say here, natural join seller. Let's spell it out. Okay, that will do the job here, but we are not finished. Now what we need to say? We are saying, so we don't need to, okay, so now I have to have the rest of the where clause. Let's get the red color again. And what's the where clause says? Where clause simply says color is equal to white or color is equal to blue. Okay, so that's what the where clause here will be. All right, I don't have any room to write the where clause. I can write it here. Okay, where color equal to white or I'll make a capital, or next line I can use here, color is equal to blue. Closed. Okay, now you can't have two where statements. Okay, I see some of you, I don't know, just copy from each other, and I see some people have copied. I know who have copied. Okay, because I look at the paper, I know exactly who has copied from where, and they have exactly the same answer and exactly the wrong answer. Same wrong answer. Okay, there are no two where statements used one after the other. All right, this is it. There's nothing more. Time is going to be up. If you have some question, ask me quickly. I told you now that in the book they use 1 and infinity for relational diagram. That's not what I'm looking for. I'm going to be looking for UML notation. So you guys have to learn the UML notation. If you don't know it, learn it. It's not hard.
UML notation is just 1.1.m.
Yes. Well, people are using some kind of completely part of Peter Cham circles or part of something else. I don't know. I don't know why they don't want to learn it. Okay. Well, I can't help. That's if it is, that's the way it will be. There will be no partial credit for anything if you don't do the question as it asks you. And as I also told you, I write it all the time that if I can't read something and you give me a paper which is so tiny and also all messed up, I can't read it. If I can't read something and you have all messed up paper, you won't get any credit. So remember that. This won't happen now.
I have a quick question about exams. So are we going to be printing out the paper and then doing it by hand, or we could do it online?
No, you have to do online. Actually, you have to stay online here too, because this is, will be monitored.
Okay.
But you can also say, for example, you're doing EERD or relation diagram, you will have a file. You can, do it on a piece of paper and then,
Oh, do you want us to have our cameras on for the test?
Say it again?
Or you want us to have our cameras on, you said, or?
I didn't get it. What was that, Michael?
You said we're going to be monitored. Do you want us to have cameras on? Or
Yes.
No?
Yes.
Oh, okay.
And anybody who cannot have the camera on, they can take the test in school.
Okay.
I will make the arrangement. They'll go to school.
I know you've repeated many
And
times.
this will be a closed. Oh, one more thing. Just hold your horses. This will be closed book exam. Remember that. Okay. One more thing. I have. Anybody wants to take a copy of this? I just want to talk about something else quickly. Anybody wants to take a copy of this? Okay. Done.
Yeah, I'm done.
Well, you are done, Michael. Maybe you don't need it. But you need it too, because group buy, okay? Please understand this group buy, okay?
Yes, sir.
Carefully, please study this.
Yep.
Having class. Oh, 1 minute, 1 minute. Where was I? Just 1 second. Okay, just one question here. Here is a question. This says number of colleges applied by each student, right? Each student. Now look at 1, 2, 3. How many colleges this Amy applied to? 3 colleges. She applied to NJIT, Stony Brook, and Cornell. Yes?
Yes.
Okay. All right. Supposing over here, I want student SID, but I also want student name. Where do I get student name from? Right from the student, right?
Yes.
Okay. Now, if I want student name, I can say here S name, and my question still be correct. Okay, here is the problem. Let me tell you. In group by, we only had SID. We do not have S name. If something doesn't appear in group by, it cannot appear in the select statement. Okay?
Okay.
Now, in this case, that is not a problem, because for every SID, there is a unique student name corresponding to that. Okay? So no problem here. So even if student name is not here, you can put the student name in the answer. Now, let's look at another example where this is not going to work. Let me show you. Just 1 second. I think I thought I put it down. Okay. All right. All right. Now, supposing we did put over there distinct C name. Okay. Supposing. Okay. So this question says number of colleges applied by each student, right? Supposing we say student ID and we also want student name, no problem. What about if I say C name here? What will happen if I say C name? Right here, if I say I want to also C name, what will happen? That won't work. Why? Because every student may have applied to more than one college. So what college name you put here in the answer? System will put what name? It may put some arbitrary name. Choose one of the arbitrary names, but it make no sense. It won't work. Okay? But student name works because wherever there is a SID corresponding to that, there's a student name. For every same SID, the same student name. Okay, so that works, but this one will not work. Okay, now the only other thing I wanted to say was, okay guys, just note this down, okay, that whatever appears in group Y, that is the only thing which can appear in select statement except the aggregated functions. Okay, the other thing I want to say to you is that we talked about acid properties of transactions. Make sure you understand that. A stands for atomicity. That means a transaction is made up of many steps, but it's indivisible. That means either all steps are carried out or none is carried out. When all are finished, the transaction will commit, and its committed changes will be durable, permanent, okay, persistent. Even if the system fails, crashes, even then it will be persistent. What happens? We do logs of the transactions, and when the system fails, you go back and you can grade the system, update the system to the data points you want. Okay, and C stands for consistency. C simply means that all the database is always in a consistent state, and when the transaction is applied, it should leave the database in a consistent state. Just like I told you, some of the consistency requirements, like a student can only register in CS 4550 only once, not twice. Okay? And then I stands for isolation. Although many transactions are happening at the same time, executing at the same time, but they still behave as if each one is going by itself. Why? Because we make sure they are conflict serializability, and so that any schedule they are going through, it is equivalent to some serial schedule. Okay, it's written. I gave you in the handout. There's a whole page, number 4. So make sure. Okay, so all businesses which are really critical businesses, like banking, like telecommunication, any of those things, data is critical, right? And critically is important. And any business who also gives you bills, even the utility companies, telephone companies, anybody, they will always use transactions which are ACID. They cannot use non-SQL business. Their database is always SQL database, not non-SQL. It's okay if you are using Facebook or something. Nothing, no problem there. There you use no SQL, but not in critical applications like I just mentioned. Okay? All right. So good luck on everything. And anybody needs to talk to me about any of their project, just send me an email and we'll try to schedule something.
Will do. Thank you, Professor. Have a good night.
Enjoy yourself.
Thank you, Professor.
You too.
And good luck on your exams.
Thank you.
Thank you. Good.
Bye.
Thank you, Professor. Okay, one thing I just wanted to clear, I know that it is, you've mentioned it a lot of times, but I just want to make sure that it is that way. About relational diagrams, it doesn't have foreign keys. So it has primary.
Wait a minute. What is it? Relation diagram what?
Yes, what makes a diagram a relational diagram?
Relational diagram is where all the relationships are shown using the foreign keys, and all